times it by 100, that's right. So what is that going to work out to? When I multiply this by 100. So I have 105 centimeters. Okay, so I want to find the area of the door. So what are the dimensions for the door then, now that I've changed that to centimeters?
105, 30, and 40.
Okay, but just the door. Just the door. What's the dimensions of the door?
105 and 30.
105 by 30. And how do I find, that's a rectangle, you agree? So how do I find the area of the rectangle? Length times width. So let's take 105 centimeters and we'll multiply it by 30 centimeters.
Wouldn't that be just the surface area though?
Yep, that's right. But that's all I'm doing, right?
Okay.
Because I'm going to put the wrapping paper on the door itself. So I only want the surface area of the door. Okay? So 105 by 30. And it looks like it works out to, what is it?
315.
I think that's right. 30 by 105 should be 3,000 something. 3,150 centimeters squared. Okay. So far so good? It didn't give us any specific, it did not give us any specific units, so we can use whatever units we wanted. So that's why I leave it like this, right? Okay. And then it says, how much space is in there inside the locker for the balloons? When it's asking about how much space, what are we talking about now? Volume. And how do I find the volume of a rectangular solid? Beautiful. So all I got to basically do then is take this guy, right, and times it by 40 centimeters. So take that number and times it by 40 centimeters, and what do I get?
126,000.
126,000 right on the nose. Thank you. Centimeters cubed, right? So far, so good. Any questions? Any questions? Okay. Now, let's say then that they wanted you to do it in meters squared and meters cubed. So again, my thoughts are I would change these. So I would change this. So if I was doing this question again, I would change this to 0.3 meters and this to 0.4 meters. Okay? And then I would multiply 1.05 by 0.3. That would give me this in meters squared and so on. But let's say, for instance, then that you did want to use the area squared in order to do it. So I need to convert it. So again, I'm going to show you what I feel like is the simplest way to do it without having to remember. Okay? And that is this. I draw myself a square. That square is going to be 1 meter by 1 meter. So what's the area of it? 1 meter squared, that's right. Okay? And how many centimeters are in a meter?
100.
So it's 100 centimeters by 100 centimeters. And when I multiply 100 centimeters by 100 centimeters, what do I end up with? 10,000 centimeters squared. So even if I don't remember offhand, or it's not on my sheet, it should be on a conversion sheet, but if it's not, that's how I would simply do it. All right? So then I would take this 3,150 centimeters squared times 1 meter squared over 10,000 centimeters squared. And that equals
2.31.
perfect. Thank you. Okay? So the second section deals with just area and volume of objects. All right? We're still using the same conversion factors, units, whatever, that we used in the first section, but now we're going to apply it to actual areas and volumes. Okay? So there's not much more to know than that. What we'll do then is take a look at 2.2. How many of you are, there's a number of you away of Tuesday, Wednesday for French, right? Okay. I'm going to go through most of this then right now. And then all we'll do then is you're not having to actually catch up. You've got all the information and you can just work on it, okay? That makes it simpler. All right, so Take a look at page 24. So on page 24, the most important thing is to look at the shapes that are given to you. Now, if you look at one from last year, okay. I only need to photocopy that then. Okay, I have that. All right, so I'm going to give you the shapes and you have to find out the areas and volumes of them. But I'll give them to you, so all you need to do is apply. But the one I want to look at, the two that I want to look at, are the pyramid, the right pyramid, and the right cone. Okay? And let's start with the cone. So, that's a radius R. This is my slant height. They're going to use the word slant height for you because there's two types of heights. And we're going to use both of the heights. We need them. So this makes a right triangle right here. So this is the height of the pyramid. So if you look at the equations, the surface area of a cone. So the surface area of this cone.
Pi r squared plus pi r slant.
Okay, so pi r squared plus
Pi r s.
pi r s. Excellent, thank you. Okay, so how many of you had a drumstick before? Anybody had an ice cream drumstick?
Okay.
Yeah. They're wrapped up like that, right?
Yes, that's what a percussion instrument.
Okay, so when I take the top off it, all right, that's the bottom right here. That's some surface area to it. That's pi r squared because it's a circle. And then when you unwrap the rest of the drumstick, right, wrapping comes out, still has the shape. It almost looks like a rectangle when you actually unwrap it. Okay, so to get the area of that part of it, I take pi times r times s. Now, what happens if the height is given to me, the vertical height, but the s isn't given to me? Do we know how to calculate that? Really? Do you think you know?
Would you do like a triangle?
Okay, I would. Right? So to get it, I take my height here.
And squared and radius with c squared.
Very good. I would take h squared plus r squared, and that would equal to my slant height squared. So there is that option to do. Okay? And what is the volume of a cone? Did you come across it yet?
Pi r squared height over 3.
Over what?
3.
Three?
1/3 pi. 1/3 pi r squared height.
Very good. Both of you are absolutely correct. Pi r squared h times 1/3. Now, what if I did this? I've created a cylinder. How do I find the area, the volume of a cylinder? So like a can of soup.
2 pi r squared plus pi r
H.
h, yeah.
Okay, you just told me the area.
The volume.
What's the volume first? And then I'm gonna come back to it. What is it?
Pi r squared plus.
Okay, so I want you to think about this. You have a can of soup. So we're going to take the top off the can of soup, right? We're going to take the lid off so we can pour the soup out of the can, right? So when I cut that lid off, that's has an area of pi r squared, right? Now if I envision taking it and sliding it back into the can after I've cut it, all right? I'm going to take that area and I'm going to multiply it by that height going into that can. That gives me the volume of it. Now a cone is the exact same thing, except it has 1/3 the space. That's how I end up with this right here to get the volume. It's 1/3 pi r squared h. It's 1/3 the volume of the can. Okay? So none of that you need to really remember. All I'm doing is just trying to show you where they come from. All right? And then you have to be able to apply it. Okay? Now, take a look in your book at the front again. And so it would be page 14 and 15 at the very front. So Roman numeral 14 and Roman numeral 15. So that's XIV and XV. And what do you notice? You have all your equations there. So rather than me photocopying today, I will for the test, but rather than me photocopying today, this is where you're going to get your equations from for your book. And all you're doing today is areas and volumes of these objects. Okay? Any questions?
There's 2 points.
Emma, go ahead.
When we're going for French, is it just those 2 units?
We'll probably get into 2.3 because we're gonna have all day today for 2.1, 2.2 on Tuesday, and 2.3 on Wednesday. Okay? So if you're in French, probably expect to be into your review by Thursday next week. All right, it's a pretty short section, and we've already done all the conversions. 3 takes a little longer because there's more conversions involved. All right? Everybody has Power School?
Yeah.
Yeah, so we all know that your marks are on there from your test yesterday, correct? Anybody not on Power School? Okay, you're all good then. Perfect. Okay, I have nothing else today. You have the rest of today to work on 2.1. Go ahead.
I have my money downstairs.
Awesome. You want to go get it?
Yeah.
Brooklyn.
When something is like 2/3 or 1/3, when we put it into our calculator, do we put it as 0.3?
No, do 2 divided by 3 and then multiply it, or 1 divided by 3 and then multiply it. Okay?
So 1.2.